Good morning, students. Today we'll be learning about Alfred Wegener and how he discovered the secrets of plate tectonics.
That's exactly right. Without him, we would never know about the different types of plate boundaries or tectonic plates at all. Earthquakes and mountains would be a mystery to us.
That's a lot of plate movement, but how does that cause whole continents to move that far? What are the different types of plate boundaries anyway?
Many scientists thought that Wegener had no evidence to prove his theory, and even his father-in-law thought his work was meaningless.
Wow, how did he overcome those people and find evidence for his theory?
Seafloor spreading and all these types of plate movement is really what caused the continents to drift apart on their own. I've heard of Alfred Wegener. Isn't he crazy?
Is that all the evidence he had for his theory?
Yes, that is how Wegener discovered this theory. He wasn't necessarily a scientist, but he had a PhD in astronomy, an interest in geology, meteorology, and climatology. Wegener first began to research this idea when he had read a study about fossil types and how scientists found the same type of fossil in 2 different countries across the world. Wegener then drafted his story called Pangaea, meaning all lands in Greek.
Wow, Alfred Wegener really helped the scientific world develop.
Wow, that's a lot of evidence. Did the other scientists believe Alfred then? But how is this possible? It would take a long time for the continents to move where they are now. Yeah, the continents can't fit together.
What do you mean he's crazy? Without Alfred Wegener's knowledge, we would never know what we know today about plate tectonics.
Is there anywhere where I can make
Beep, beep.
should I
Well,
get really
looks like class is
excited about
over. Have a nice day. Well, other scientists had some evidence that furthered his interest in the theory. An example of a scientist that helped Wegener is Harry Hess. Hess discovered and researched the spreading of seafloor. Before this, people thought that the seafloor was smooth, but Hess discovered that it's actually filled with large valleys and mountains. This supported the Pangaea theory because continental drift is likely to have caused the seafloor spreading. That's right, but many scientists thought his claims were absurd like you do. Even though they sound crazy, the continents were actually formed together a long time ago. It was called Pangaea. Learned lots of new stuff today in class. How about you?
Yeah, now I know all about plate tectonics.
Hope you enjoyed the video.
See you later.
Well, tectonic plates are the different pieces of the lithosphere that make up our Earth. There are 3 different types of plate boundaries, all with specific types of movement and effects on the Earth. The first boundary is the divergent boundary, which is where the 2 plate boundaries are moving apart. This type of movement has two different effects on the Earth, an oceanic ridge and a rift valley. An oceanic ridge is a long underwater mountain range that is formed at a divergent plate boundary. When the two plates move apart, convection currents rise in the mantle beneath the oceanic crust and create magma where the two plates meet. This forms the ridge or mountain range. This type of movement is also the cause of seafloor spreading. A rift is a lowland region that forms at the divergent boundary after tectonic movement. This occurrence is created by tectonic activity, not erosion. The second plate boundary is the convergent boundary, which is where the two plates move towards each other. These plates have three effects on Earth: ocean-to-ocean plate movement, ocean-to-continent plate movement, and continent-to-continent plate movement. When oceanic plates converge, the plate with a higher density will subduct under the less dense plate. This forces melting in the subducted plate because it is forced into the mantle. Magma chambers are then produced because of the melting, and can reach the surface of the lithosphere to cause volcanic eruptions. If the magma chambers become more frequent, they can even build to become islands like Japan, the Aleutian Islands, and the Eastern Caribbean Islands. Another effect of convergent boundaries are oceanic to continental plates. Much like the oceanic convergence, the more dense plate, which is the oceanic plate, will subduct under the continental plate and is melted by the mantle. Magma chambers are once again produced by this, but due to their low density, they are buoyant. This buoyancy allows for them to break through the lithosphere, and if they do not solidify, volcanic eruptions can occur. The Cascade volcanoes in the coast of North America are great examples of this. The third and last effect from divergent boundaries are continent-to-continent convergence. In this process, there is no subduction because of the low density of the plates. These plates simply collide and sometimes create mountains if fragments of crust is between the boundaries. Notable mountains that happen because of this is the Appalachian Range or the Himalaya Range. The final plate boundary is the transform plate boundary, which is where the two plates slide past one another. This boundary only has one effect, which is called transform faults. Transform faults are created when two plates are moving away from the spreading of a divergent plate boundary. This can cause massive earthquakes depending on how much pressure there is between two plates. The San Andreas Fault is a great example of this boundary. No, not at all. Wegner knew that other scientists could easily explain away his seafloor spreading and continental puzzle ideas, so he decided to find more evidence. Wegner had 5 main points to explain the continental drift, 4 of which turned out to be correct. The first is the similarity between coastlines on opposite sides of the South Atlantic Ocean. The second is the fossil remains of the now extinct animals like the Cenogathus and the Litrosaurus that were found in 2 entirely different continents, but were the exact same species. The third point is that the rock types that were found in particular regions on one continent closely match the age and type to rocks in adjacent positions on different continents. The fourth is that the continents were joined together during the glacial event, and Wegner found that there are glacial deposits showing that between 220 and 300 million years ago, ice sheets covered large area of the southern hemisphere. The fifth and only main piece of evidence that Wegener was wrong about is that the plate movement was caused by tidal influence in the moon's strong pull. After this research, Wegener managed to keep the idea of the continental drift alive in order for people to discover new evidence like tectonic plates and how they move. It wasn't until after Alfred Wegener died in 1930 when scientists started to believe his theories. At this time, other scientists like Vine and Matthews had started to research seafloor spreading and magnetic strips on the ocean floor, just as Harry Hess had done. This time, scientists noticed a pattern in the way mid-ocean ridges formed and mantle convection produces a new oceanic lithosphere. Soon people began to develop evidence about this occurrence, like paleomagnetism, which is the natural remnant magnetism in rock bodies that is used to determine the location of the magnetic poles at the time the rock became magnetized. Because of this newfound evidence, scientists came to the conclusion that tectonic plates existed.